Welcome to our Labcafé online. We have over 300 registrations. Thanks a lot that so many people are interested in one of the most exciting lab projects in the world. My name is Alexander Biller, and I'm looking forward to share a lot of inspiration with you. Our topic today, Roche pRED Innovation Center, Thinking New Dimensions. The new pRED Center of Roche will be one of its kind and break with existing industry standards. The building complex will be home to the brightest talents from science and Roche pRED's new corporate R&D setup in Basel. The project team's target was nothing smaller than to make the most out of a once-in-a-lifetime opportunity and to reach a new level of modularity, flexibility, sustainability, and user experience. And I'm so proud that we have the chance to meet the people behind this project today. Impulse number one is focusing on the question, what are the project's key drivers? From Dr. Geo Adam, he's Global Head of Research Infrastructures Projects, and he's an innovative enabler of future-oriented lab buildings and sustainable user-centric workplace concepts. Dr. Adam, it's an honor that you're on board and will give us insights of the visions and ideas behind the project. Impulse number two is about why do we therefore need new concepts? From Achim Grenz, he's project manager, pRED Innovation Center. Achim is pushing the project every day with all his passion and knowledge to a success. Achim, I'm so happy that you're taking us on a journey through the project. And impulse number three is about how can these concepts and solutions be tailored more specially to end users' needs. It's from Daniel Zimmerli. He's co-stream lead medicinal chemistry. Daniel is one of the very engaged user representatives for the new pRED building. And Daniel, I'm so excited that you're part of our event to share the user's perspective to this project. At the end, we have a Q&A session. So if you have questions, write it in the chat. And then I would say, let's start. Take a good cup of coffee and be inspired by the place where the Roche magic will happen and the best scientists of the world will create solutions that help patients live longer and better. So Dr. Adam, it's your turn.
Thank you very much and welcome from my side. I will start to share the slides now and then get going. First, let me start with some disclaimers, right? I mean, of course, we're all honored and blasted away by all these fantastic words from the introduction, but we are quite a modest bunch and we are the user representatives that you see on screen, so Achim, Daniel and myself. And of course, the major task, right, is not done by us, right? It's done by an extremely diligent engineering team in Basel under the leadership of a colleague called Markus. And to steer and to make this ultra complex project happen, right, is something that really demands the very best of what is around. So kudos to that team, and we are only the users who set the high bars, right? And many other people have to lift the projects over these high bars. So let me start. I mean, I used already that expression. For many people on the call who are architects or planners or whatever, right? They do every year, every second year, third year, a new project. For the users, this is a once in a lifetime chance to create their work environment where they can work best, right? And so it's very humbling. If you imagine, you will see the size of the project later. And yeah, you have to try to think the future. You don't know what you built for. I think that is the key message. Science is changing fast, technology is changing fast, and usually, you know, while you finish a building, you will have to redo it because things have changed. Not all of it, but parts of it. So let me talk about the background. I mean, the drivers of the project, I guess they are similar to many, many projects in the world, maybe with one difference. So modernization, the Basel site was built in the 60s and 70s of the last century with value money and Librium money. And so most of our research builders reach the same age of 50, 60 years these days, right? Which of course is a big risk of cluster if the building fails. The environment is not really made for new technology, especially when it comes to heat dissipation. And so there is a need for a new environment. In addition, I said it already, the buildings are from the 60s and 70s last years. If you compare that to what is around in the world, right, you need to do something to attract the talents to Basel. And then what is unique to that project, there was just a window of opportunity to run this project, and that is that a huge building plot in Basel was made available for that project. And there was a time of 2-3 years to really grab this chance. And we were lucky that our new head of research at that time jumped in and could convince our top management that we need to do something with regard to lab environment. This is a bird's view. If you look at the site Basel at the moment, and all the red dots is where the research colleagues are housed. And you can understand in a business where collaboration is key, this is not made for success, right? If you imagine that colleagues who work on the same project walk 50, 100 meters to see their colleague, they never meet by accident, only by scheduled meetings, then it's clear you have to do something. And in the future, we would like to have a picture which is much more collaborative. So 3 dots only. The 1 dot, this is what we will talk about, the big one, which is the pRED Center Basel. Then another dot here in the north already built. This is the new animal house, which went online, which is a beauty and a spectacular project in itself, but not for today. And then the last dot we have is for our large-scale chemistry labs that we have, and galenic labs that we still need to find a place for. This will be a follow-up project of the one that we show. So where do you start, right? You start by looking and stealing with pride and looking what others have done. And we embarked on a quite extensive tour to look at the best research centers in the world. Best in that sense that colleagues who joined us from everywhere in the world said, oh, I worked for some time there, and it was great because of. So it looks like a lot of fun, but I can tell you it was a quite stressful event going through the US in a week and looking at, I don't know, 12 of these buildings in 6 different cities, but it was worth it, right? You see what works good, you can talk to the guys there, you find out what is not so working well, and then you can take the good and the bad with you. And what we learned and what we need to do all basically is summarized on this slide. And you see the distribution of labs on the Basel campus, and for pRED especially also in the world, right? We saw centers where really people identified that the center was a means to identify yourself with your work and what you do, right? We wanted to use that building to set up an identity for our research unit. We wanted desperately to increase the efficiency of interaction, right? We will show later how we do that. Communication and collaboration. Those of you who have been to Basel may know that our buildings, as they are more a single lab, double lab environment, right? So 4 doors to open before you see the next scientist. Not really prone for communication. And then, I said it before, what do we build for? Right, so the key part of this building is the flexibility. We do not know in which disease areas we will be in 10 years. We do not know what technology we will need to use to work in this new fields of research. So we have to make sure that the building can adapt to whatever comes. One basic concept and of the building was, how do we plan it? So how, from the user side, always from the user side, how do we involve the right colleagues to plan it? And this very colorful picture should show you that we did not plan for departments, right? Here's on medicinal chemistry, the others are abbreviation of Roche departments that we have at the moment. And we know from other projects that then usually the department head of A and B and C delegate somebody and they take part in the planning. This was not for us, right? We wanted to plan for what is needed in the building, so for the functionality of the building. So of course, a lot of offices, then many labs that fulfill tasks in biology research, many labs that take part in the automation, analytics, storage, you name it, part of the work, the medchem labs, and then in addition, so this is the physical environment, let's say it, and then of course, what do we do with regard to the IT world? How is that changing? That is an additional project in itself that we have started. And what can we do to improve the collaboration, communication, project work in that buildings? So, and for these groups, and Achim is, for example, the stream lead of the automation part, right? And these stream leads and Daniel for the medchem, he's the deputy there. We then recruited knowledgeable colleagues from each of these functions to form a team that will help us to plan the layouts of the building. The second thing is the age of these people is a very important thing. And very much in the beginning of the project, we run workshops on basic questions. And we should not forget, right, that all the bio boomers will go into retirement 25, 26, around that time, right? And usually in these project teams and also in the user teams, we have this group of people overrepresented, right? Which of course is wrong, because you need the young people who should work there to give the input to create the right environment. And so whenever possible in these workshops, we try to have at least 50% of generation Y in the room to give the input, especially with regard to the soft factors that I showed before, right? I mean, biology research is not so dependent so much whether you're a baby boomer or a generation Y person or generation Z even. But what is important is, how do you communicate? How do you collaborate? So the softer parts of the building are very important to hear and to listen to those people. So let's dive into the project a little bit more. This is the new pRED Center Basel, and you can see it's 4 buildings, of which really, in honesty, only 3 are the pRED Center Basel. And this is these 3 larger buildings. 2 of the larger ones are lab buildings with a vertical facade, and the one, the smaller one here is an office building. And by the way, I think Markus Hammers is online. Markus, hello. Just to say hello. I mean, the very first steps, the project initiation we did with Markus Hammers from Hammers Krause Architekten, and it was fun, Markus. Thank you very much. And too bad we could not keep you on board, but that were other reasons. So you see the 2 lab buildings and the office building underneath. There's of course, there's a little bit 2 floors of support work with air handling and all that kind of stuff. And then we have a 4-story underground parking garage under it. We also have a bicycle parking in that complex for about 1,500 bicycles. The 4th building, which I didn't mention yet, this will be a convention center and will also for a time house top management because their building will also be renovated somewhere. And so for that, we have a point where they could go during that time. We have maybe some specificities here. We have the entrance. There's only one main entrance. There are few yeah, side entrance, let's say, but the main entrance, we want to funnel the people all when they come in the morning through that main entrance into building 7, and then distribute through the avenue. The buildings are connected through means avenue. You don't feel like leaving the building, right? And then if you look very carefully on the slide, between the big lab buildings, you see 2 sky bridges, which connect the buildings in 6th and 13th floor, just to make the way of the scientists easier if they need to go from one high scraper into the next one. We have a cafeteria with a scenic view to Basel here on floor 14. And we have a very special room up here that I will show in a minute, a whole floor, because we did not put our management on the top floor. I think that also is a little bit the concept, but we put our management in the middle, so that the ways for the researchers to meet the top guys is easy, and they are in the middle of us and not somewhere away in an ivory tower. And the top spot up there we used for the scientists, and I'll show you in a second how. So as I said, one of the key things were collaboration and communication. And communication usually requires cool locations, right? You need to create spaces where people love to go, because then they go there, and if everybody goes there, people meet. And these are the unplanned meetings, which usually are bringing things that you could not plan for. And so let me quickly introduce you. In the right bottom corner of the slide, you see the image of, you see a little icon of the sender. And if you look, you see that every 3 floors are connected, right? Form a unit, which we call a neighborhood. You see there are lab neighborhoods and there are office neighborhoods where we have office floors. And if you look at the normal floor, you see we have the labs and we have the offices where the colleagues sit, or rather the writing desks where the people sit. You don't see enclosed offices. I hope you recognize that. Just separated by a hygiene wall. And we have stacked this principle 3 times on top of each other and connected it with an open circular staircase in the office part of the floors. And so we have this combination of labs and offices, and Prim will later allude to how we can change that. We have on the middle floor, which you cannot see, there is a little kitchenette where people, this is the place where you get coffees, you know, so our hope is people go down 1 floor, up 1 floor from the lowest one of the neighborhood to meet in that marketplace, what we call it. And there are also larger VC rooms and additional meeting rooms on the floor. This is not the latest layout. We have 6 one-to-one rooms where people can go if they have to do something confidential or need just more quiet work time. These 3 floors, we are mixing about 140 scientists, and I guess what is quite unique to that building, although of course we got the idea elsewhere, right? What is quite unique to the project is that here we mix different specialists in this neighborhood. So we don't have the pure chemistry building and the biology building and the whatever building as you know it from other companies usually, but here we mix chemistry, biology, technology in one of the neighborhoods. And this neighborhood is the size of a good startup, right? 140 people. You can drive projects with that number of people in there. That was the reasoning behind putting that into these neighborhoods. Here you see an architect's impression, a side view to this open staircase in the office part of the building. You see it's transparent. Also here the parts of the staircase are transparent to ensure that you really see who is around on the lower floors, and that you can just reach out to them and say, hey, let's go for a coffee, let's discuss some science. This is a lab into the look into the lab floors. You see the huge lab floor. So whenever science or safety is not dictating us to close off a lab. We leave it open to improve the sharing and to improve the collaboration in the labs. All instruments and all the things except for medicinal chemistry that you see are shared. So the colleagues don't own the instruments anymore, but they belong sort of to the floor that we look at. Let me just, before I hand over, speak a little bit to the 23rd floor, this top floor that we didn't give to top management for offices. And this is a floor that we use to first of all be able to run projects, right? If you are projects in a hot phase and you need to just a room where you can close off and bang on each other for 2 weeks, right? Then the normal meeting room environment is just not good enough, right? You need a space where you can leave the stuff and you can leave the writings on the wall, whatever you have on the table, just don't touch it. And for that, we built 6 project spaces into that floor. And the project space basically divides this floor from a very quiet zone where you can meditate, where you can have a nap over lunchtime, whatever you need a quiet environment for, from a zone that is more team building style and a little party zone, if you wish, to celebrate the milestones that we hope to celebrate in the future, right? So if a team of 20, 30, 50 people needs to celebrate a milestone, they should come up here and just enjoy it. No need to go outside, right? More time for science. Also, what we brought back into this floor, you may recognize it, is a real library, right? All these fancy books, right? They don't die out. No. They're still there, right? They're on the shelves of our co-workers, and because you saw the space where the writing desks are, we had to provide space to have all the very expensive science literature available in a classical old library room. Just a last look, and then I hand over to Achim. Again, bird's view, but looking a little bit at the surrounding of the pRED Center. So here you saw the 3 buildings that I just talked about. There is another cafeteria, which I didn't mention so far, on the ground floor here on the cafeteria, looking out to a square with trees where you can work outside. And so this is part of the pRED Center, for which, of course, it's part of the site Basel, but we were very, very lucky and happy and very grateful that this building plot here was not used for another building, but that we could use it for creating some campus feeling on the site. Here you see the convention center with the auditorium and the classroom, the ground floor, which I mentioned before. And then the science square is sort of rounded up by a real pub where you can watch football and world championships and whatever, and ice hockey, whatever, or the Super Bowl, whatever you would like to watch, right? Just in case you stay long enough on the site in the evening and couldn't make it home in time. Also in that building, we have a gym, we have a grocery store, and the doctor's building, so the medical service of the site is just in the next building close to that one above here. So you see that the strive to create sort of a little research campus, right? Very small in a dense environment on the Basel side, that should show how you could enable that. And with that, I would like to hand over to Achim, who dives a little bit deeper in the concepts of modularity and flexibility. Achim, over to you.
Thank you, Geir. Great. So for the next 10 minutes or so, I'd like to take you a little from this whole building kind of picture into a single lab space, because we're talking lab buildings here and looking at the one thing, and Geir mentioned that also in his part, is we need to be prepared for change, and that is simply imminent to any research. We will always have change. It will come over the lifetime of the buildings in many sorts and phases and shades, and we will just have to be prepared for that. That is what actually drove us to create the technical environment that we have in our labs. And I come to this other point, minimizing downtime, also telling you, next slide, please, Gear. So again, a bird's eye view. This is not the whole building. This is a single floor, and it's a typical single floor. I see blue to the right and to the left. This would be an only lab space, and only lab space means it follows all safety and environmental health requirements. So you have to have lab coats on. There is no drinking, no nothing in here. The other side, the yellowish and the reddish part, this is where the office area. So in principle, you can think of a lab floor being split 50-50 to one of each sides. And why we or what we chose here, and again, it talks to points Geo mentioned, mix of functions and then flexibility, is when we see that we have deliberately more space for seating than we would anticipate that people would be sitting working in the lab area. So the yellow space would actually fit, as we assume in an initial setup, for all the people that actually work in the lab. Now the red space is identical. It's the same thing. It's just other, just colored different. That's the only difference to that slide. And that is, if we change the number of people working in the lab, there's no way that we need to find another room or need to extend the lab or something like that. We simply use these spaces. And if we change less, we just fill up the unused seats with people that are usually not working in a lab area. So that is it. So that's one part of how we can flexibly deal with a changing number of head count on a specific floor or in a specific group, be it for temporary reasons, having postdocs coming in, or be it for longer project reasons and so on. Next slide, please. So this slide tries to tell that story a little bit. On the bottom line, you see the double error, then single error, double-ended errors and single-ended errors. And on the green slide above, that's it, like technical installation. We don't see a difference in the technical installation that we have made between the right of space that you use as a lab personnel or the offices or the meeting rooms. It's all interchangeable. You can all convert one into another, either by simply reassigning it or reusing it somewhat differently. If you go to the labs, be it the normal biology, pharmacology labs, most of the automation labs, and closed labs, we put the machinery. Again, we have one level of installation. And actually, it's almost true for the entirety of the lab. The only exception actually is chemistry, and chemistry just simply uses higher air volume. So we needed to have a little wider HVAC ducts here to do that. So this is one direction. What we have a chemistry lab today, we can sort of repurpose as a biology lab, what we can't do otherwise, simply because of the air handling that we need to do. Next slide, please. Now, looking at how flexible or how different we can use that space that I just showed is here's four out of, I don't know, 25, 30-ish different possibilities how we use that space in the lab area. And what you see is every blue box is basically a lab, no wall in between, a open space, and they can differ widely from the tiny little squares on the top left-hand side to the bigger ones on the top right-hand side. And the size here actually vary from 11 square meter-ish to greater than 300 square meter-ish on this side. What you can also see is, and you mentioned that too, the separation wall that divides a lab area from an office area isn't a fixed position. Actually, we can move that slightly to the left or to the right, depending on how much lab we need, how much office space we need, or what the lab dimension is. So the way we look at it is that we wanted to create a very flexible space that we can customize to the purpose of its user in the lab area. And if you need to separate for different biosafety levels or something, you can simply build walls and then create that space. And if you don't, you can go open and so on and so forth. Next slide. So in a bit of a summary is the flexibility that by actually creating the rooms that we work in is twofold. On the two left-hand pictures, you see we can actually have the size of the entirety of all labs by this fire compartment setting wall. We can have that in 4 different positions on each and every floor, and these positions are defined in the first place. So it's all set up that with not much ado, we can actually build a wall there or move that wall from one place to another. And that's actually probably the most demanding change that we would ever do to a lab floor, changing the size from going from like 350-ish to 500 square meters of lab size on a single floor of those 30 plus floors that we have. The right-hand side of the picture gives you the picture, checkerboard picture. These red lines are all the positions where we can put separation wall to create these different sized labs that we would need according to the needs of a customer. So if today you have quite a big lab and your new technology is coming up in 2035 and you need to isolate that because it's either noisy or it requires different or it has a lot of heat dissipation or something like that, we can actually put on any of those positions. And you see here, we can place a wall, and the building here is already set up to do that and to make that process easy. Next slide. So to actually be that flexible, it requires rules and it requires some kind of guidelines or restraints, and I'm very thankful for all the technical planners that actually came up with all these possibilities and these rules and actually made it happen. It's a great job. I haven't seen that anywhere else. So what we do is right now, because we do not know what happens in 2035 or 45, we supply every floor and every lab identical. They get everything the same. So we got all gases on every floor. We got all separation wall preconditions on every floor. We get all electricity on every floor. We get everything on every floor because we simply do not know how we would use it in the future. That is generally, so you can basically copy paste the floors from one to another, and that does apply to a standard set of media, completely agnostic of any initially planned or occupant, completely agnostic of who's moving on the 7th floor in building 7 in 2024. One example, 7th floor 27 is a chemistry floor. I haven't seen many chemistries, even though I'm trained myself, using carbon dioxide gas in their reaction. There are some, but usually it's not mainstream. Still, the carbon dioxide gas is also on that floor because, remember 2 slides back, we have this downward compatibility. So we want to be able to convert a chemistry lab into a biology lab, and then we may need it, or parts of that. So that technically was a really long exercise to come there and make that happen and have all this pre-installation and mounting fitting all in quite a narrow headspace or ceiling space that we have here. It is only I don't tell the number because it may be wrong, less than a meter as far as I know. And really pack all this pre-installation and all this this only concept-wise, but not first fit-out wise required stuff in there. So we have the positions where we can mount the walls. We do actually have quite a modular system how we can change the cooling capacity of a single room, no matter what size. And that can go. There is a factor of 2 or 3 into what we can in what we can do in terms of heat capacity per square meter in every one of those if we wanted to. And again, we also we looked at that in very many details on various aspects. And if it comes to drain board or gas or electricity, everything needs to be looked at that time, and it worked out great. However, at one point in time, you obviously come into issues. You can't fit everything in there, and you need to know where your boundaries are. And some of that, like steam supply, very rarely used, and it's difficult. Steam pipes are usually quite big and insulated and so on. They wouldn't fit in there. So we knew and we defined, okay, this is what standard is, and here we come. We take the exceptional. The exception to the standard and change the modularity and the standard setup that we have because it is, for example, biosafety level 3 laboratory, which has simply so different requirements that you just cannot build it everywhere, and we may not need it everywhere. So everything, 99% of the space or 90% of the space is actually absolute standard, and we only fit it out to the needs as we have today, tomorrow, and in 10 years from now. And there is a little space or parts of the space that are somehow different. Next slide, please. So You remember that checkerboard, this 340 by 340 grid within the lab. Now, if you apply all these rules and if you're really diligent, and it's been a fantastic job by the technical team here, you can actually bring all the standards into that 111 square meter piece. And that basically enables us to have a module or a part that we actually can attach to each or can combine to each site, and then we can have put 5 in a row or 7 in a row, and each one of those is actually capable to build a lab from a texture wise. So it does have the air, it does have the media, it does have everything that you want. So in theory, on a 340 by 340, you can just put a few walls around and you still have a functioning lab, and you wouldn't have to change a single pipe or something in the ceiling. This is what we have. And that is all fixed. We call that the fixed installation in the ceiling. That is what was built first. And now here comes what we as user are looking to. In also, changing that means you don't want to touch the ceiling. That is all fixed, but you want to change or customize your lab, and this is why you need a modular lab furniture system. And we follow the very same principle here. Again, next slide, please. It is a modules. We take all the media that we would need on a bench, whatever the requirements are, we take them from that fixed ceiling, take them down one into a floor-mounted spine system, as we would call it, make all the horizontal distributions just above floor level. And then we attach the furniture to it. And whenever we need media, we actually have little boxes, we call them media boxes, that we put on top of that, on that horizontal distribution piece, that spine piece, and take the media from there as we need it. And in here, this is where you finally see visibly the difference between all these labs, except from the walls where the ceiling is all fine, it's all the same. This thing, these part of the labs, they are highly customized to all the needs of all the different labs. So next slide, and last slide it is. Why do we do that? A little back to the business case. We can, or we have built that system in a way that we can, or we build it agnostic from any functional use that we know right now. Building may have 40, 50 years of life cycles. We have no clue of what will happen in 30 years, but I think we are well prepared to actually accommodate and that in that time. And here comes a little bit of the business case behind it. If you have big labs and if you have 30 people in there and you need to do some reconstruction because you want to do a wall or you want to put in a pipe, that takes time. What do you do with these 30 people at the time? So basically your downtime in the lab cannot be long. And what the engineers and the architects and technical people proved here, and we've done that in a mock-up, we can basically change the size of the lab on the floor within a month's time. So I say, okay, we ramp it down only 4 weeks and we have an entirely different looking floor, be it all office or be it double-sized lab space, that we can do. Even further, if we do that in the lab and simply separate a part for let's say a noisy room or something, or by a BSL2 level room, we can put up these walls that we've been talking of within 2 weeks' time. And on top of that, we only do that where we actually place the wall. So most of the lab around it can continue working while that's so we don't cut any supplies because it's already in there. We simply need to remove the former benches, put up the walls, do quite a number of things actually to have this wall mounted and then put in the other stuff, but we can fit that in 15 days in 2 weeks only. So basically, if a new PI would come or a new researcher would come or new technology should be implemented, we can take a 500 square meter lab and make it a 300 and a 200 days in only 2 weeks' time. And that's great. When it comes to the very individual customization of every single lab, every change of the lab itself and the furniture, every change, as long as it's not a fume hood or something really big, we can do in half a day. So if there is this one chemist that has this reaction that does need carbon dioxide, I don't know whether it should be, probably not, but we can actually bring it to the desk or to the hood in half a day. If someone needs to have a 400 volt 16 amp socket, we can bring it down, install that within half a day. without interrupting much else of that thing. There's no one actually drilling. There's no one actually opening the ceiling heavily. We should be able to do that on Monday morning and Monday lunchtime. You can work with that. So this is the kind of flexibility, the technical flexibility that we have here. I haven't seen anything like that in these tours that Geo said on. I think we are kind of set for future change here, and this is the technical side of it. With that, I think we're drilling down even further. I hand it over to Dania on the very specifics in the lab. Thank you.
Thank you, Ari. I'm live here in a demo lab in building 92, around 200 meters away from the pRED center. And behind me, it's the 2.10 meter fume hood where we will work in the future inside. To realize that, to manage everything, we started 1.5 years away from now, a digital way of working group, addressing the needs in a shared lab. And this is our mascot here. Maybe this mascot help us a little bit through the hard days we have. We have only 1.5 years from now to go inside the building, and we are not ready yet with everything that we would want to do for the digital way of working. You see here, we have 150 laboratories in these 2 buildings, 6 and 7. Then we have the 24 lab floors on the screen, and we have 100 meeting rooms around and everything. And the neighborhoods are 15, what Geo told in the beginning, the 3 floors working together, and everything has most connected together. That's is a hard work for the team, and we will see how we can work with our future. Go on the next slide. You see here again the same picture. We have the lab to office segregation. We have a wall between. At the moment I am here in the lab. Behind of me you see the fume hood, and I can work on my office desk, go 2 to 3 meters to my work desk in the fume hood. But in the future I prepare my experiments in the yellow zone and go in the blue zone. Maybe have to do something in the back in the other blue zones. And you see behind and the bottom we are 30 meters to walk through, and that's need really good connections for the future. We have also here, I have my own, maybe my own chromatography machine. In the future I have to share the machine, and also with the logistic I have everything here in the lab by my own. Sometimes I have to take a chemical somewhere, and in the future we have everything to share, and we have a multi-state storage that Geo shows you in the middle. We have a conveyor. They bring from the bottom the chemicals up in the floor where you work. In an hourly basis, you can order something, and 1 hour later you have your compound in your logistics zone. You can pick that up and you go back to the lab to working with. And then these are the parts where you're working on at the moment. This one-stop shop, inventory management, material tracking, and tracing stuff. And also we work for equipment management tool. I come later to that, and the lab management tool, the tracking. We have a lab interface for the equipment and lab interface for the integration. That means we want remote monitoring when you sit in the yellow area, and you can directly connect it in the blue area by a webcam. You see the webcam, I show you later, but you see the webcam up to me in the new fume hood. Then you can directly look what is working with your experiment, or how is your rotoweb, the distillation of your stuff that is finished, and you can stop directly from your office, or maybe in the future, maybe from your home. You can directly have a process to do by the remote controlling or remote monitoring. And I will show you later then in the next slides here. At the moment, you plan experiment, then you have prepare the materials. I will give you an example when you're looking at the moment for the reagents or the molecule. When you build a molecule, you need reagents. And at the moment, we are in an 8th floor building. I go on my computer, look where is the reagent. Sometimes it is in the stockroom, this is in the ground floor, and sometimes the reagents are I have maybe 3 in the 3 different locations in the 8th floor building. Then I print out the paper, I go there, the lab, I ask the people, they are looking for the reagents, doesn't found it, when somebody else have taken that away. And in the future, I hope so, we have then a really good system with barcodes and RFID tags on the flask. And then we know everywhere, every time, where the compound is in the building or in your floor. We have scanners around in the floors, and then it's easier to find new material, and you can save a lot of time with this new material tracking system where we want to work with. And also, in the next step, prepare the equipment. At the moment, you have everything by your own. In the future, you have to book your equipment. In the biology lab, you have also you book the tables sometimes, and that need a really good system that you see every time in the morning or in the evening what is free, then you can book it, and that makes the life much more easier. That was to prepare the space. You see it in the upper. Then afterwards, you run the lab work. You see the second part of the box is note taking. Behind you, we will install on every fume hood or on every workplace. We have maybe a screen or a tablet there. Then you can you have direct access to your ELN or your lab journal, and you can taking the notes. Also on the balance station, you will take the notes from your experiments real time to your lab book, and you never will have a lot of paper or no small pieces of paper where you written the tars from the flask or something else. I hope everything will finalize then in this lab management tool, that we can work paperless from in the office and in the lab. We go then to the next slide. We go a little bit deeper in the laboratory. You see a little bit the fume hood here, where it's behind directly of me. When you see a current fume hood in the labs, they are mostly have not a lot of glass, only the front wall is glass. Here we have everything on every side. You have glass. We have a glass table too. At the moment, when you see we have a ceramic one, we have a lot of problem to that. When we work with chemistry work, and the highlight of the new fume hood will be the high adjustable. I think it's the first fume hood that I've seen in the lab area where the fume hoods can adjustable by high, and we have an 8 degrees sloping front. That bring you, when you're working on it, it brings you really nearer to your experiment, and also for your back and it's more easy for the ergonomic work. And we have the food switch. You see it on the left side, the food switch open directly the fume hood by food when you have a full hand. We have the webcam integrated. This is on the right side of the picture. On the top of the fume hood is black hole. And we have a tablet holder. You see it on my right side. And the new fume hood is really quiet. It's around 50 decibel. We also developed this one with the Waldner company, and I think we do a great job all together to have a good result at the end, and the chemists will happy to work in this fume hood. We have also made with company A&Z together a new weighing cabinet. This is also the same design with the glazed side walls. We have a black table inside here. This looping front again. Then a tripod table. You see it stands on 3 feet. It makes the more stability for the weighing process. We have an electrostatic bar inside for the lyophilization product. They are flying around, and with this electrostatic bar, you can work much more better with these special compounds. The ergonomic armrests are the blue ones in the picture at the front of. This is much only a quiet machine. It's around 45 to 50 decibel. In the working mode at the moment, we really loud weighing cabinets with around 60 decibel. We have a tablet holder, also integrated there. Everywhere we have to connect it to the lab. And we have in-table waste management. This is not showed on the picture. This is the small ring in behind of that. We will become in a few months the end version with this table waste management. This is also a totally new concept in a weighing cabinet. Yeah. We are a group. We have a biology committee. We have a medchem committee. We involved a lot of people in the process to go in the pRED center. On the left-hand side picture, you see the Labcafé bio committee. They are working now on a biobench. On the right-hand picture, this was the first visit at Waldner around 3 years ago, or maybe a little bit more. This was the first prototype of the 2m10 fume hood, where we have at the moment behind of me. In the middle, we have some small gadget, and the share, where you see this is made together in collaboration with our medical service. This is the new first prototype of the new lab chair from the company Donati, and we are waiting. We have tested that a half year ago, and we're waiting now for the second part of the prototype. And then last picture, you see the new tablet holder. I have it also here in real directly. This is the new tablet holder, also developed together with R&Z. It's flexible and we can use it on a fume hood. We can use it on a bench. We can use it on a weighing station. We can use it on the bench. We have only one part for use in the whole building. Yeah. Here you see the building in November 21, and you see the backwards building or the building number 6, and behind that number 7, and you see open windows. And at the moment, when you go from the Gensacherstraße to the building, you see the walls are closed now, all windows are in, and they are working hard with around, Theo told that, or Achim, with around 700 people on the construction site for the 40 floors for the inside to build the lab. Yeah, I think I give over. Thank you, Alexander, for the Q&A session.
So thanks a lot to you three for sharing so much insights, ideas, and graphics and photos. It's really amazing, and it's a big challenge to rock it. There are a few questions. I would say we start with you, Dr. Adam. Where did the input for the ideas come from?
Well, as I said, we basically asked every scientist around, where did he work before, where did he come from, what did he like at that institute where he worked, and why did he like it, and then combined that with the tours where we could look live at these buildings. That gave us the ideas, right? So steel with bright. Whenever we saw something interesting, we wanted to have it. Whenever we saw something that doesn't work from our point of view, we wanted to avoid it in the period center. So it's really that collection of knowledge of the scientists.
Okay, thank you. And also to you, Dr. Adam, what does it take besides money to get such a thing off the ground?
Well, I guess I mean, the complexity of that thing is just, yeah, hard to describe, right? And I think it needs a very special project team to be able to cope with such a huge and difficult, and we have not talked about COVID, right? We have not talked about the logistics problems at the moment, and to run such a problem alone is a very, very demanding task. If to run it in times of COVID and in times of where you don't know where you get your material from, right, it's just a miracle. So I think it requires dedicated, hardworking, smart people in the engineering project team who runs the whole show, right? And yeah, and it demands, I guess, also from every company that works with us, right? It's the complexity, right? I think this is not one more of the usual project. It demands everybody to go to his limits, and it demands from everybody the yes, we want to do it, and yes, we can do it thinking. Otherwise, it will not happen.
Okay, a question to you, Achim. What were the biggest challenges and barriers in the planning or in the implementation process?
That's a good one. I'm probably not able to sort of rank them in a way. What's the biggest or what's they come all the way down. So we've been planning that for years in concept phases, and there's so many facets to a single detail. That could be regulatory constraints, that could be working constraints, this could be user experience constraints, and so on and so forth. That actually basically pushing, going in loop and going over individual parts of the system all over again in the design phase. And we had many of those, and took a lot of tenacity actually to keep the momentum and keep it doing. And again, here, kudos to the planner team, kudos to Marcus's team. Basically they kept on listening to us for years and years on end, and then we are still not finished. And now with the building going up and with the construction being on and the fit out being here at, yeah, it's probably hyperspeed level at the moment. You will always find, and you do have these issues, but you need to find ways around. And I simply echo what Geo says. It's kudos to Marcus and his team. They run this show, and there are surprises all the time. That's fine. You cannot imagine a project of that complexity going smooth. Like, I planned that 5 years ago, and there is no issue. I just need to implement it. It doesn't work, obviously. The amount of extra lengths that this team goes to actually make it happen and discuss and then revert and find another way. This is extraordinary. And I consider myself very, very fortunate to be able to see that and observe that from a sideline way, because execution is really a big thing. And as I said, there are many things, some of them bigger, some of them less big, and yeah, kudos to the team.
Okay, thanks, Achim. another question to you, Achim. Concept and reality. You showed us many concepts, modularity, flexibility. Now the building is on site, and you're walking through the building. What is the feeling? Before you only had the 3D plans and drawings, and now you're in reality and have the real sizes, the heights, the depth, and so on. Were there any unexpected surprises?
Yes, but positive ones. Easy. So walking in first time, seeing the size of the room, seeing the transparency that we actually aimed for, seeing it all panning out, not from a 2D monitor screen, but seeing a real, that was really, I think that is great. And if you get the feeling for the rooms, the size of the rooms, the way it's going to be fitted now, that is really fantastic. No doubt. I think reality is that was really astonishing. So I became accustomed to the BIM models and seeing every detail and almost every screw or holding in virtual. And now you look up and you see it. It's that different color. BIM models tend to be very colorful. Here it is more like the steel and metal type of. But yeah, you see it. It's there. So it's being translated from computer into reality, which is also a very good one. I think the challenge that you will have when you go on such an endeavor, it's not only to build it, that's a huge challenge, no doubt, but it's to sustain it over time and to keep these concepts alive for the 10, 20, 30, 40 years to come. And really to make sure that the concepts that we've been thinking, why a pipe is right here and why it's not over there, because it could be easier or shorter to put it on the left, on the right side. No, you need to put it on the left side because, and there is a concept behind it, to take that into the lifespan of the building and to sustain that over time. That is a challenge we will still have to face. And I think there is a lot of bright minds in engineering onto it. And yeah, let's see how that works. I'm sure we will get there, but it is a big change here as well, running a building over time.
Okay, the next question to you, Daniel. Which points were particularly important to the users, and how were the scientists involved?
Yeah, we started really early to involve the people. We made, as I told that before, we have a bio committee, we have a chemistry committee. We work strongly together. We took them the ideas from them. We managed as team lead. We managed this list and go to the project team and build the fume hood or the weighing bench or the bio bench from the ideas from the customers or from the scientists. These people will have to work there, and not me too, but Geo and Achim not working there. They're sitting in the yellow area and looking us over the shoulder how we work in the lab. But the people from the lab, they are important. Their ideas are important, and every project we handle with, we involve the people, and this is good. Yeah, this is totally new also for the lab people, and this is a new way of working. It's not it's really great to have everyone on board, and it will also in the end it's a win-win for everyone. People knows in where they work. We have the fume hood in real behind of me, and this fume hood is the same fume hood that the people work in the pRED center.
Thanks a lot, Daniel. Yes, I think, and we see that also in other projects, it's so important to involve the employees and the users at the very first beginning. This is so for the change process, for the acceptance, for everything. It's the most important thing to involve them as early as possible. And another question to you, Daniel, is there or how will the users and scientists be prepared for the new building? So they come from an old world to a new world, and is there a training program or something like that?
Yeah, it's hard to say. We are working on it. We have now around 1.5 or 2 years time to realize that, At the moment, I sit here in a small lab, maybe 2 or 3 people works here. In the future, we handle in the biggest chemistry lab 28 people in one lab, and this is, we have to share equipment and also the reserve equipment. This is not easy to bring the people in the future there. Here we have a demo lab. We can made a few things here in the lab. We can build up, and we will build up this year a small farm. This is a farm from around 3 or 4 equipment. In the future, we have a farm from 8 to 10 equipment in the lab. We build it here up in this demo lab, maybe with 4 equipments for special parts. And the people, they have to come here. They don't have to work in the lab. They have to work here in this demo lab, do the separation and go back in the lab. And then we can handle with the remote control. They can go back to the lab. You see, they have longer ways to do that. And with this small workshop or these small experiments, we bring the people near to the pRED center. The time is 1.5 years, and this is not a lot. And I hope so. We hope so. We can bring the people more together. They have slightly work now together and not in their own small area. The important thing, everyone have to go on one string to work hard together, yeah. And then we become a nice result, and we become also a better communication in the whole department. Yeah.
Mr. Adam, you raise up your hand.
Yeah, I wanted just to add to what Daniel said. Of course, this is a huge change management program overall, right? So Daniel alluded a little bit to what we do for the chemists with that integration lab, whatever you want to call it. But there is, of course, there is a lot of things to relearn, right? I mean, your waste, right, will not function like in the old buildings, right? Your whole logistics will work differently. So there will be a huge change management program which we just setting up, and as Daniel said, we have about 1.5 to 2 years time to bring the colleagues up to speed. So yeah, and this is a big project in its own. It's just a change management project.
Okay, there's another question in the chat regarding lab furniture. It looks fixed to the floor. Have you considered to use free workstation connected to seating? Yes, no, why? So perhaps Mr. Adam?
I hand over to Achim.
Ah, okay.
Yeah, it may look fixed, but it's way more flexible. And we could probably talk half an hour onto what that system is and what system can do. There are tricks that you how you change it. There is fast removal of parts, and yes, it is. There are floor mounted spines, as we would call them, and we can remove them, we can shorten them, we can elongate them in almost no time. So the system is highly flexible. Having it all on wheels and only connected from on top of the ceiling is not ideal. We do that for certain devices and equipment rooms. We do exactly that. So we still have media columns there in some, but this system has the beauty that you have this extra support layer in the middle. You have an 80 centimeter depth table on both sides of that thing and 20 centimeter in the middle. So right now, all I need to do is move that little box aside, and I have a 1 meter 80 wide table of whatever depth I need in there. So it is highly flexible. And yes, we can change it really, really fast.
Great. So the last question for today goes to Dr. Adam. The pRED Innovation Center is the tallest building, I think, in Switzerland. What did Basel say about the plans when you showed them?
So the highest building in Switzerland is building 2. It's also a Roche building.
Okay.
It's about 210 meters, actually not next, but one building away from the pRED center. But we are not sure, and maybe somebody in the call knows better, but we think it may be the largest lab building for sure in Switzerland, right? For Europe, I guess so. Yes, for the world, I don't know, right? But which has labs up to 100 meter, right? Well, Basel is just very, I guess Switzerland as a whole, and especially Basel, is just very, very special. Me as a German, you know, to talk to the authorities and to get, you know, Basel, Roche remade its campus in the last 10 years with building 1, with building 2, with the pRED center, all skyscrapers in the middle of a rural, normal Wohnbebauung in German, you know, where people live, right? And it was a dialogue, right? And the dialogue led to that we could build it. And I would bet in any German city, right, in that environment, it would have taken decades, and it would have taken 100 Bürgerinitiativen, so whatever you call it in English, right, to hinder that, right? I think the Swiss people and the Basel colleagues really know where the wealth of the country is coming in part from, right? A third of the exports of Switzerland stem from pharmaceutical industry, a third, right? And people know where their wealth is coming from, and that's why they are very supportive. So, but of course, again, the project team did a lot to help the neighbors, right? I mean, having a construction site 10 years next to you is not fun, right? So there was a big program in the project run. How can we listen to the neighbors? How can we ease their life? What can we do to make them accept this lengthy building period? So it's just a great environment for doing these complex projects, I guess.
Thanks a lot. And thanks a lot to our 3 speakers, to you, Dr. Adam, to Achim, to Daniel. It was a real pleasure to hear and feel all your engagement and passion to this incredible project. And now I look forward, not to the year 2024, but to the next Waldner Academy event. Our next Labcafé Online will be on the 13th of April, and we will talk about well-being labs. And my guests will be Norbert Schachner from HDR, Dr. Lena Reis from Dresden Sommer, and Dr. Devi Schönbeck from Steelcase. And I can say, together also with Steelcase, we made some studies how combining lab area and office area in different possibilities. Yes, we have great topics. It would be a pleasure if you meet us in 2 weeks. Thanks a lot to our 3 speakers, and have a nice day. Thank you.
Thank you. Bye-bye.
Bye.